In today's lesson, we are going to look at using or finding future and present value of interest questions using TVM solvers. So TVM solvers are just basically like a financial app that you can find in some graphing calculators as well as online that allows you to quickly calculate interest calculations or scenarios without having to go through and actually use the interest or the compound interest formula. So it will do that for you. All you have to do is enter in some key information depending on the scenario. So the key information you're going to have to enter or find is you're going to have to find n, which is the number of periods or what represents the term of the investment or loan. Right? So it's same as kind of the n in our formula, the total number of compounding periods or the total number of payments, whatever the case may be. I% represents the interest rate. In this case, all we have to do is leave it as a percent. We don't need to convert it to a decimal or divide it by the compound number. The TVM solver will do that for us. PV represents the present value or principal, so same thing. PMT represents the amount of regular payments. Now we haven't talked about payments yet. We're going to cover that in a future lesson. So we can leave it at 0. Essentially, what that means is we're not putting in additional money on a regular basis. FV represents the future value or the final amount. PY or PPY represents the number of payments per year. And CY or CPY represents the number of compounding periods per year. So all information you can get directly from an equation, from a scenario, and we enter it into the specific spots into the calculator, and then we click on the missing one or what we're trying to find and solve for that. There's one extra thing on a physical calculator. You do want PMT to have it at the end. So you want to make sure the end is highlighted. And this is only for when we're using the calculators. The TVM solvers online tend to already assume it's at the end. And all it really means is that you're putting in the payment at the end of each interval. So at the end of the month or at the end of the year, at the end of the week, not at the beginning, right? So that could affect your calculation slightly. But we're going to focus primarily on using the online TVM solvers just because it's easier to access and a lot simpler to use. Even though it's the same program, it's just easier to get to. So we're just going to look through a couple of examples and we're going to use TVM solvers to basically get the answer for us, but we want to figure out, or we have to figure out what we need to fill in first. So we want to determine the future value of a $500 investment if the annual interest rate is 4.8% compounded monthly for 3 years. So some key information that's easy, the 4.8%, that's our I value, so 4.8. We don't need to convert it to a decimal or anything. Our present value, our PV, $500, that's how much we're starting with. PMT is 0, we don't have any payments. Future value, we don't know. Payments per year, again, it doesn't really matter what you put. You could put 0, but because our payment is 0, we're not really adding anything. So we can leave it as 12, and generally, in some calculators, the PY will stay the same as the CY. In this case, our CY is compounded monthly. So again, most calculators tend to assume that whenever your interest is compounded, that's when you're adding in another payment. And then our N value, the number of years, or the length of the term or the loan, or all the payments. So in this case, because it's compounded monthly for 3 years, 3 times 12, or 36. So now what we can do is we can go to our TVM solver. Now, if you Google TVM solver, you'll get plenty that come up, but you want to Google TVM solver GeoGebra, and we can kind of see the two here, but GeoGebra, just to get them to come up first. So we have the two here. Either one works. The main reason, though, I like using this instead of some of the other ones that come up is because these ones allow you to enter in specific values for PY and CY. In some cases, like we kind of just mentioned in our example, it will automatically assume that whatever the compounding periods are per year, that's what your payments are per year. But in some cases, that may not be the case. It may be different. But now that we have our TVM solver, we can go through, enter in our information. So 36 for N, 4.8 for I, PV is 500, PMT is 0, FV we don't know, so we'll leave it. PY is 12 and CY is 12. Now all we have to do is just go over to FV, click solve, and we get that after the 3 years, we will have $577.28. So again, that's how easy it is to use the TVM solver. You don't have to go and actually do any calculations. You just have to enter in the values and solve for the specific part. Now it does show up as negative on our TVM solver, and the negative implies that we don't have the money, right? So in this case, the money is in an account. We don't physically have it. So that's all it really means. But as long as you understand that you can't really be losing money in these scenarios, you can just disregard the negative. Looking at the next question, how much money will Tony have in 7 years from now if he invests $8,000 at 8% per year compounded semi-annually? So again, we can go through and find out the key information. Again, some that stick out: 8,000, 8%. So 8%, we start with 8,000. We want to figure out how much we're going to have. PMT is going to be 0. It's compounded semi-annually, so that's twice a year. PY, we can just put 2 down as well. Not that it matters because the PMT is 0, so we're not adding anything. And then the N value is 7 years times twice a year equals 14, right? Because it's going to be for a 7-year period, or 7 years from now. Then again, all we have to do is go back to our calculator. We can change our values. So 14, 8, 8,000. We can leave the FV as what it used to be. Change the last two. And now we're just going to click solve for FV again. And now we have our new amount. Now you might need to click on the box to see the actual full decimal places or the 2 decimal places. But we can see that our future value after 7 years compounded semi-annually at 8%, that $8,000 will become $13,853, I believe it was 41 cents. Yes. So again, main thing is just finding the values and just entering it into the TVM solver. We don't really have to do too much more than that. The main thing is just understanding what the variables represent, so that when we go through and solve, it's a little bit easier. So next example, Tina needs $2,500 10 years from now. How much will she need to invest today at 12.5% per annum or per year, compounded monthly, to reach her goal? So again, this one's a little bit different now because she needs $2,500. So that's her future value. 10 years from now, so the 10 years will be important. How much would she need to invest today at 12.5%? So I is 12.5, compounded monthly, to reach her goal. So CY is 12, PY we can put 12 down, PMT is 0, PV we don't know, so we're going to leave it. And N is 10 years multiplied by 12 months equals 120. Again, now that we have all our variables filled out, we know what we're looking for. We can go back to our TVM solver, enter in the new values, and this time we're going to click on solve for PV, and we get, again, it is negative, but we were going to disregard the negative. We get $720.91. So that's how much Tina needs to invest now at this specific rate, compounded monthly. so that in 10 years, she will have $2,500. One last example. So this is a little bit different because in this one, we're not looking for the future value or the present value. We're looking for something else. The process remains the same. We're still going to go through and find out our key information, plug it in, and then try to use the TVM solver to solve for what we're looking for. So Mr. Liu wants to invest $10,000 for his son so that it will become $500,000 when he reaches 60 years old. So two key pieces of information there. We have our present value and we have our future value. When he reaches 60 years old, that will be important. If the interest rate is semi-annually or compounded semi-annually, what rate should he be looking for? So compounding periods will be semi-annually, which will be twice. Payments per year will be twice. PMT is 0. I, we don't know. N is the total number of periods. So in this case, 60 years times twice a year equals 120. Now we're going to go through and solve for I. So again, we can use the TVM solver. Same thing. Just change our values. So 120 stays the same. I, we're looking for. PV is 10,000. PMT is 0. FV is 500,000. 2 and 2. And we click on solve for IV. We're not getting a value. I think in this case, we do have to make sure that 1 is negative. It doesn't want to solve. Let's see if we can clear it. 120. Unknown. 10,000. 0. 50,000. 2 and 2. Does look like it's solving for something, but perhaps the interest rate is too large or too small to work. I'm going to hazard to guess that it might be too small. So let's try a different calculator. Let's see if it works. And the other ones, so 120, we don't know, 10,000. 500,000, 2 and 2. So it's not giving us an interest. Again, let's just check. There we go. So now this works. So this one works. So we just had to make a few adjustments. Right. So again, this might, if you're looking for rate, this calculator may be better. But we can see once we have the negative in there, it does work. So we should be looking for an interest rate of 6.63% in this account or whatever the situation may be, where we can turn the $10,000 into, or the $10,000 into $500,000 over the 60 years, compounded twice a year. So again, the main thing is that we can use a TVM solver to easily do these calculations for us, rather than having to use the compound interest formulas for future value or present value. It makes it a little bit easier because all we have to do is just find some key information from the scenario, plug it in, and click solve. Right, so again, just make sure you understand what the variables are. Go back to that page. Make sure you understand what the variables represent, and then just how to access the TVM solver and use them.